So now the concept of 9.3 dependent samples or matched pairs is this. This section presents method for testing hypothesis and constructing confidence intervals involving the mean of the differences of the values from two populations that are dependent, in the sense that the data consist of matched pairs. So then the pairs must be matched according to some relationship, and such as before after measurements from the same subset or IQ scores of husband and wives. Okay, so definitely we assume that we do not know population means. Okay, so you see, when designing an experiment or planning an observational study, using dependent samples with matched pair is generally better than using two independent samples. So because the using the matched pair, we can figure out the correlations or of the between two sample data. Okay, so better than two independent samples. Okay, so yeah, definitely what we did in 9.2 here or so, we gonna figure out how to do a hypothesis test and the confidence interval, how to figure out the conclusion about the hypothesis test, and then how to estimate the confidence interval. Okay, so here the idea is simple. The first one, we're gonna find out D. What's the D? We're gonna find out the individual difference between the two values in a single matched pairs. Okay, and then we're gonna get one single sample data set. Okay, that sample data set is consist of individual difference between the two values from the matched pairs. Okay, so once we get the one single sample data set, we're gonna find out population of that sample data, mean sample data set. Okay, mean of sample data. I'm sorry, and then the standard deviation of that sample data set. So mu d is the mean value of the differences d for this population of all matched pair of data, and the d bar is the mean value of the differences d for paired sample data. Okay, so we're gonna find out d bar, which is a sample mean. Okay, and the sd is a sample sample standard deviations, and n is the number of pairs of sample data. Okay, so do not confuse with these the notations. Okay, so now here's the requirement. This is pretty much the same as the requirement what we have seen 9.2. Okay, sample data must be dependent, which match pair. Okay, but in 9.2, one of the first requirement was what? Two sample data must be independent, right? But here, the sample data are independent. The match pair are simple random sample. And then here's step 3, pretty much that what? The samples must be, the sample obtained by taking difference between two values from the dependent match pairs, dependent samples must be normally distributed. Okay, so for the since we do not know the population standard deviations, we're gonna use t-distribution. So we're gonna find the test statistic. Okay, for the hypothesis test, right? So give me a second. And then the margin of error E. So for the confidence interval, the BUD, which is the difference between the two population means, okay, is bounded by D bar minus E, D bar plus E. So that's the formula of E, but you don't have to you don't have to use this one, okay, because we're gonna figure out that using calculator. So now here's a procedure. So let me explain the procedure by solving one example. Okay, so here's example 1. Are best actresses generally younger than the best actors? So data list ages of actresses when they won Oscar in the category of Best Actress, along with the ages of actor when they won Oscar in the category of Best Actor. The ages are matched according to the year that the awards were presented. So this is a small random selection of the very available data so that we can better illustrate the procedure of this section. Yeah. Use the sample data within 0.05 significance level, so alpha is 0.05, right? To test the claim that for the population of ages of best actresses and a best actor, the differences have been less than 0. Okay, so from here we can figure out the null hypothesis and then alternative hypothesis, right? So the definitely what second the null hypothesis is going to be, see right there, this one. Yeah, definitely the null hypothesis is mu sub d equals 0, right? Okay, mu sub d equals 0. So then the claim is what? Mu sub d is less than 0, right? Claim right here. Mu sub d is less than 0. So what's the mu sub d? This is the sample mean. Okay, keep in mind that here the sample mean means that what? For given two dependent samples, we're gonna construct the one single new sample data set, right? By taking difference, by calculating individual difference for two values from the two dependent samples. Okay, so from so the mu d is that sample mean. Okay, mu of d is less than 0, right? Because the right, and then if the original claim is not true, we have mu of d is greater than equals 0. Okay, so now anyway, so definitely null hypothesis always equal sign. Well, the equal sign must be always must be included in the hypothesis, right? So mu of d equals 0. Okay, and then since either one must represent claim, so alternative hypothesis must represent claim, right? So mu of d must be less than 0. Okay, that's an alternative hypothesis, and the H1 is original claim. Okay, so now, okay, so now the what's here, we're back to right there. Okay, now anyway, we need to figure out the we need to construct the one single sample data, right? So by taking difference for each pairs of the data, okay, 28 minus 62, 28 minus 37, okay, all right. So then what if you have to deal with many more than 5 data set? What are you gonna do? So there is a way to calculate the differences automatically using calculator. I'll show you. So first you need to enter the dependent samples. Okay, I enter the two data set, the age of actresses and the age of actors right here, L8 and L7. You can just enter those two dependent samples in L1 and L2. Doesn't matter. Okay, so, but I did that, and now we leave that mode. Okay, give me a second. Great. Sorry. So now what are you gonna do? Give me a second. I forgot what this. I did. I entered the L6 and L7, right? Okay, L6 and L7. Great. And then I'll just enter the first one. We press second, and then press stack. Then you can see a list of column list. Okay. I'll subtract L6. I enter the L6. Okay. You may just I'm going to do this L6 minus L7 and then store that result into the other list column. Okay, so then you may just manually just enter the column name, for example, alpha and an L, and then one like this. If you do this, sometimes you may get error. So I don't recommend you do this. Okay, instead of that, you just use this second list stack. Okay, to go to the list, and then you choose the column name, what you want, enter, minus L6 and then minus L7, right? Stack L7. This is L7, right? Okay. So now we just give me a second. Yeah, I just enter L6 minus L7, but this you can see it looks like this is double L, lowercase L, and then uppercase L. That's fine. So I don't know why, but when you just choose the L7 from the list, you can get that double L. And then now to store the result into the new column, other column, we use this. See that STO means store. Store L. Let me enter. Let me store the result into L2. So press list and L2. Choose L2. Okay, so enter. Okay, so we get this. This is much better than just manually calculating by hand. Okay, so once you do this, what are you gonna do? Give me a second. So now we're gonna go to the stack and then test. They use t-test. Okay, we use this one when we deal with one single sample data, right? In a hypothesis test, right? So since once we construct the kind of we made two samples. I mean, we made we created one single sample data using the two dependent sample data set, right? So now the rest of them is pretty much the same step as what we did in the chapter the 7 and 8. Okay, so t-test, okay, is the user data, okay. The mu0, actually here mu0 must be mu sub d. Okay, so mu sub d is what is we 0, right? Because the claim is what the differences have a mean less than 0, right? So mu sub d is less than 0. So here mu sub 0 must be 0, and then list must be L not 1 but L2, right? L2. Okay, the frequency loan is a little bit, and then what's the alternative hypothesis? Mu sub d is less than 0, right? Mu sub d is less than 0 that we calculate. Okay, now you can figure out test statistic. Test a statistic, right? T value, and then P value right there, 0.09. Now the problem says that what signal level is 0.05, right? So since PBL is greater than 0, right? So we fail to reject. Okay. So now let's see. Give me a second. So we conclude that there is not sufficient evidence to support the claim. Okay, so mu sub d is less than 0. Okay, which means that there is not sufficient evidence to support the claim because we failed to reject the null hypothesis. Okay, so and then alternative hypothesis is the original claim. So so there is not sufficient evidence to support the claim. Therefore, the population of ages of best actresses and best actors, the differences have been less than 0. So there is not sufficient evidence to conclude that best actresses are generally younger than best actors. Okay, so but now let's see more detail about the about the steps. How can we not just beyond of that, the methodology using calculator. Okay, so let's figure out those steps in detail. Okay, in that is on the PowerPoint slide. So here, first we need to check the requirement, but I didn't check that, right? So, but normally you can plot the quantile plot to see what points are points are lies on the straight line. Okay, so let me skip that one because I did that many times in other previous lectures. Okay, a couple of previous lectures, so please look at it. So then you can see how to plot the normal quantile plot of the for the sample data set. Okay, so the three, you have to check the three requirements. First one, the two samples are dependent, match pair or not. Okay, should be match pair. Okay, and then simple random sample. Normally, they assume that the samples collected by random sample. Okay, they are a simple random sample. I mean, okay. So now, and then what I did here, show what I did. So using t-test, once we from there, we got difference t. That's a new one single sample data set. Okay, and then using that sample data set, we calculate the using the t-test, the command in the calculator. We figured out the t-test, statistic, and p-value. Okay, and then x bar. Here, x bar is actually mu bar. Okay, so sample mean, and then actually sx means the mu sd. Okay, the sample standard deviations. Right. Okay, and then step one. So we am seeing step one and step three, right? Step one through step three is pretty much about figuring out null hypothesis and then alternative hypothesis, and then which one represent the original claim. So here, the original claim is this, by mu of is less than 0, and then so that must be H1, right? So now step 4, figure out significance level 0.05, and then step 5, we use a student t distributions. Okay, so that we figure out the t bar and then SD. Okay, because you don't have to do by hand. Okay, I told you using calculator, using t-test, t-test and calculator, you can figure out all these sample statistics. Okay, so now the p-value using p-value method. Okay, because we are using t distribution, we refer to, you don't have to refer this. Okay, so we figured out p-value. Okay, that was 0.0973. Okay, so and then since the original claim is what, mu sub d is less than 0, so you got to apply the left tail test. Okay, left tail. All right, so alpha is a 0.05. Alpha is 0.05, maybe right here, because what is alpha? Significance level is represent probability, right, of the critical value, which is what, the t value corresponding to the alpha on the t distribution that can be considered as a borderline separating significance low and then significant lower, and then just unusual and usual. Okay, right? So the 0.05 maybe be right here, but since you see that p-value, which is probability corresponding to test statistic, is greater than the alpha, so we fail to reject null hypothesis. Okay, so let me skip critical value. I think that one makes you confused. So now if we use a p-value method, we fail to reject A0 because p-value is greater than the significance level of 0.05. Okay, now so I told you this is interpretation. Okay, so we failed to reject. We failed to reject the null hypothesis, which means that there is not sufficient evidence to support the claim. Okay, so then the example 2, using the same data. Okay, we figure out the we're gonna estimate the confidence interval. Okay, so the using the same sample data, construct a 90% confidence interval. So you see that confidence level is 90%, which means that significance level gonna be the what, the 10%, right? So the significance level must be the 10%, which is 0.1, right? But see, look at this. Then the significance level alpha is 0.0. We did use 0.05 as significance level in the previous example one. Then those two, example one and example two, has different setting or different? No. See, by using the confidence level of 9%, we get a result that could be used for the previous hypothesis test. Because hypothesis test, we use one-tailed, right? Because claim is what use of these less than 0, so we had to use left tail, one tail the method, right? So now then, but confidence interval estimating, the what we consider the what both tailed test, right? So now alpha is 0.05 in a hypothesis test. The confidence interval, the confidence level must be 9%. Okay, so and then see, let's figure out the confidence interval. Okay, so for doing that, keep in mind this. So once you're just using the one the interval, okay, so t interval, I mean, you're gonna get these numbers. But before showing how to get this one, you need to understand the meaning of that interval. Okay, so keep in mind this. The interval is meaning of that interval is what? D bar minus e, d bar plus e. Okay, what's a d bar? That's your sample mean. Okay, keep in mind the sample mean of the differences of two dependent sample data set. Okay, so let's move to the go to the calculator. So here we go. Okay, here's a calculator. So the first one, you see, we're gonna use the same data, L6 and L7, and then we calculate the difference between two data sets, sample data set. We got this L2, right? Okay, so L2 right there. Get that L2. So what I'm gonna do? So here, see, a second. Oh yeah. So we go to the stack. Okay, stack, and then we see here test groups. So we use the T interval. Okay. So we choose the two options right there. We choose data, and then you enter the column name, which is L2. Okay. So now comes the interval must be not 95%, but 9%. Okay. So we calculate. So we got this. So 9 minus 24.17 and the 3.76 approximately 77. Okay, that's the confidence intervals. And then simple mean d bar. I know this is calculate x bar, but the meaning of x bar is in this example is what d bar is minus 10.2, and then d s of d is 14.65. Okay. All right. So what can you say about the met to the dependent sample in example from the confidence interval? So here the interpretation. We have 9% confidence that the limits of 9 minus 24.2 years and 3.8 years contain the true value of the mean of the age differences. So in the long run, 9% of such samples will lead to confidence interval limit that actually do contain the true population mean of the differences. So the confidence interval include the value of 0 here. So it is possible that the mean of the differences is equal to 0 here. It's just possible, okay? Indicating that there is no significant interval between ages of best actresses and the best actors, okay, based on that sample data, the dependent sample data. So, okay, so you can see this kind of pattern, right? The whenever you when you calculate the any estimate confidence interval, that confidence interval contains 0, then the you can say that there is no significant differences. Okay, so that's the one examples. Okay, so let's see one more examples in the lecture note. So this is lecture note. Let's see here. Let's see this example. Testers claim that people elected president of the U.S. have a mean height taller than their opponent at the 0.05 in single level. So then make a 9% confidence interval estimate for BUD. Okay. So now, so what you see here, for the hypothesis testing, the problem say that the alpha is 0.05 single level, but for the confidence interval, they used confidence level is 9%. Okay, well, now you see that why the confidence level must be 9% because alpha is 0.05 in the hypothesis testing. Is it taller than? Okay, then what? Mu sub d must be greater than 0, right? Mu sub d greater than 0. Okay, so we have to use the one tail test, right? Okay, then but confidence interval we gotta apply the both tail test. So we have to double the alpha, which is 10%. So confidence level must be 9%. Okay. So let me first one see figure. That's the from here we can see that that these we can get this one first. We gonna construct the sample data set consisting of the individual differences. Okay. To sample data set. Okay, and then we plot the quantile normal quantile plot. We're gonna get this. As you can see that the data are normally distributed, right? Okay. So anyway, let's figure out the hypothesis testing. Okay, conclusion about hypothesis testing. All right, so you see, since the claim is that what people elected the president of U.S. have a mean height taller than their opponents at the 0.05 single level. So claim is then you can say that mu sub d is greater than 0, greater than 0. So mu sub d is what? The president height minus opponent's height. The mean of, okay? So the mean of president's height minus opponent's height obtained by the two dependent samples, okay, given in problems. The null hypothesis is going to be mu sub d equals 0. Keep in mind is that number from the claim, okay? And then then alternative hypothesis, since the one of them should represent claim, so alternative hypothesis must be this mu's claim, okay? So that's a claim right there. Okay, so what that means, if we fail to reject a sub 0, then what, there is no sufficient evidence to support the claim. Okay, if we if we reject the a0, then there is sufficient evidence to support the claim. Okay, so now here, give me a second. So now see, we need to figure out the test statistic and p-value. Okay, so give me a second, just we got out of focus. So in the under the T graph, under T distributions, okay, so 0 represents mu sub d equals 0. So we assume that other hypothesis is true. Okay, under that assumption, we got T distribution. And the alpha is a probability that what the probability critical value G sub alpha, which is actually T sub alpha, right? So we have T alpha, okay, which is the kind of separating. This is the value separating the significant high and non-significant high. Okay, all right. So using the t test, we can figure out p-value and test statistic. Okay, so if a p-value is greater than 0.05, that means what? We fail to reject the null hypothesis, right? So using calculator right here. So first, what you have to do, you need to enter the two data set, presence high and the opponent's high, which is they are given problem, right? So I already entered the those two sample data set into L3 and L4. Okay, now we go to the just main screen, okay, and then L3 minus L4. So you enter. We need to subtract the L4 from L3, right? So we choose L3, then minus L4, and then store. You see that here. Result the store the result into L. For me, I just stored L1. Okay, so L1. Okay, just enter. I did that. Okay, so just enter. Okay, then So now what you're going to do, we go to the stack and the test and see t-test. T-test. Okay. So since we're going to use data L1 and then mu0, which is the mu sub d is 0, right? And then mu sub 1 must be greater than. Here, mu0 means 0, right? So the last one represents what? Alternative hypothesis. What's the alternative hypothesis? This mu sub d is greater than 0. So we choose that one. Then we calculate. So you see that t-test statistic is a 0.587. So 0.587. And then p-value is what? 0.29. Definitely greater than 0.05. Right? So 0.294. Okay. Then what? We fail to reject the null hypothesis. Okay. So there is no sufficient evidence to support the claim. Okay. So now, by the way, what about the normal contact plot? You had to check the whether or not, you know, the sample data, I mean, difference, okay, differences of the dependent samples data is normal disputed, right? So to check, we go to the stack plot. You had to do this first, okay? But I just forgot. So we go choose the last one. That's the normal contact plot. Okay, L1, yes, and then we zoom and press number 9. So you see that I got you see the distribution of points. The points, all points lie closely, okay, lies on the straight line. So we can say that the samples is normal distributed, okay. So well, what about the confidence interval? So we go to the stack and the test, we use t number. Okay, see t number, use data L1, and the confidence interval must be 9%. Okay, since the claim was what mu sub d is greater than 0. Okay, so we apply the one tail test, right? And the confidence interval is we apply two tail tests. So we have to double the alpha, which is 0.1, which is 10%. So confidence interval 11 must be 9%, which is 0.9. We calculate. Okay, so we got the confidence interval right there. Okay, so now since the confidence interval contains 0, right? Negative 3.15 and the 5.55. Okay, so now what can we, so what? So the what? There is no significant difference between present high and the opponent's high. Okay, so that's the all about the 9.3. Let me stop here.